Well, this lesson is going to be very similar to the last lesson because in the last lesson we talked about exponential growth functions. In this lesson, we're going to talk about exponential decay functions. So they work on the same idea, the same pattern, which I wrote out over here, so you can see they're the same pattern. You have a b value that's going to be raised to an exponent. We're going to hold the place for that exponent with the x variable, and then you'll have an a factor in front of that. So the difference between the growth factor and the decay factor is the value of b. If b is greater than 1, which is what I've have circled right here, if it's greater than 1, then it's going to show growth. So that the function, when you graph it, will grow from left to right in an upwards manner. In the decay functions, the b factor is going to be in between 0 and 1. So it's going to be a fraction or a decimal. It's going to be less than 1, but definitely needs to still be greater than 0. So that is the basic idea. That's the only real difference as far as how these functions are going to look. So if we look over at 1 through 3 on the worksheet, and they ask us to decide whether the function shows growth or decay, what we're looking at is the b exponent, the b factor. Okay, so for f of x equals 5/3 times 4/5 to the x power, the b factor, the b variable, is always what is being raised to the x exponent. So that's the b to the x part. Then what it's being multiplied by out here is that a factor. So when you're looking for your growth factor, whether it's growth or decay, you're going to be looking for b, whatever b is. So in this case, b is in parentheses there, it's 4/5. And since 4/5 is less than 1, greater than 0, but less than 1, then we know, based on this definition right over here, that this is going to show decay. So this function, left to right, is going to descend. And you can see example of that in A and B down here. On number 2, once again, we've got an A factor of 3/5. We have a b of 5/4. So our b is what's being raised to the x exponent, and it's a b of 5/4. Now, that is a fraction. However, it is not less than 1. 5/4, if we turned it into a mixed number, would be 1 and 1/4. We don't have to do that. We can leave it as 5/4, but you just need to be mindful of the fact that we can't say that if it's a fraction, if b is a fraction, it shows decay, because we could have an improper fraction that is actually greater than 0. So if it's a fraction, that kind of clues you in that it could be decay, but you need to make sure that it lines up with this principle over here saying that that b has to be less than 1. So this since it is greater than 1, it follows our growth pattern over here. And so we would say that this shows growth. And then number 3 is a little tricky, because if you're looking right here at this b value of 2, all right, so it's the one being raised to the exponent. However, it's being raised to negative x. And so if we were to actually simplify that so that we got rid of the negative exponent, this would really read 2 to the x power. Okay, so you would raise that 2 to the negative x, but then you'd have to put it in the denominator. So really, the b factor here is actually a fraction. So b here is really 1/2, so it's less than 0. And so this is actually showing decay as well. So the things to watch for in this when you're working with these decay and growth functions is to watch for improper fractions, because that can give you, if you're not paying attention, that can lead you to a wrong answer. And then also watch out for negative exponents. So now going to down to 4 through 6, where we are to match the function with its graph, we can take a quick look at each of those functions. Number 4 has a b value of 2/3. The exponent is a binomial there, so we've got an x plus 2 as an exponent, but it's still the b being raised to the x. Okay, it's still an exponent, so this is that 2/3 is still our b value in this one. The a value is 1. Just like when in any of our other functions, when that a value isn't recorded, we assume it to be 1. So this is this b value of 2/3 is less than 1, a fraction less than 1, so we know that shows decay. Number 5, the b value is 1/2, so this is going to show decay as well. And then number 6, the 2/3 is the b value, and that's going to show decay as well. Here we have an a value of 2, and number 6 and number 5, we actually have an a value of -1. So this is one that we know is going to be inverted. So number 5, we're looking for an inverted graph. All of them should show decay. On A and B, it's pretty obvious those show decay. They're descending from left to right in a curved manner. C, that one does not curve downward from left to right, so that clues us into this might be the inverted form. Okay, so 5 may go with the graph of C. We can further check it by looking at our K value out here. All right, if you remember, the K value will give you your asymptote. So K is 3 here, so that means that the line for this graph is going to approach +3, but never cross it. And so we can kind of check that out right here with C and see that, yeah, that there is an asymptote in C of 3, of y equals 3. So this is looking better and better. The last thing we can do is I'm going to come out here and write down number 5. This table is going to go with number 5, so we don't get confused later. And I'm just going to check a couple of points. So I'm going to put 0 in there for x. When I do that, that will raise that 1/2 raised to the 0 power will give me 1. But I'm taking the opposite of that, so -1 plus 3 will give me 2. And then -1 -1/2 raised to the -1st power will cause that to be reciprocated. So let me show you this one. So I'm going to raise this to the -1st. So this is the opposite of 1/2 raised to the -1st. I'm going to reciprocate this to make it a +1 exponent. And then that opposite sign ends up being there. So I end up with -2 plus 3, which gives me +1. And so those 2 points, we do see 0, 2 on the line, and we see -1, 1 on the line. So we know for sure then that C matches up with number 5. If we use the K value in number 6, right here we have a K value of -2. And if we use that K value of -2, we can come over here and say, well, if we are looking for an asymptote at -2, y of -2, and we see one right here. So that lets us know that A is most likely matched with number 6. But once again, we can come out and do a table for number 6. And if we plug 1 into there, we will get 0 out for y, 0 in for x will give us 1 out for y. I'm going to pause the video and work this out for you so you can see that how I evaluated that. Okay, so take a minute if you're having trouble with these exponents. Take a minute just to look over my algebra and see how especially how those 0 exponents work. If you can figure out how to zero out that exponent, it makes your algebra a lot easier for each of these problems. All right, and then if we look back over at letter A, we see the graph for letter A, we do see the 0.10 on the line, and we do see the 0.01 on the line. So that lets us know that for sure letter A graph matches up with number 6 function. So that leaves us with number 4, and we'll just make a table for number 4 with a couple of values just to double check and make sure that it really does match with B graph. So if in this one I'm going to evaluate at x of -2, because that will, if I say put -2 in for the x there, I'll have -2 plus 2, that equals out to 0. Anything raised to the 0 power is going to give me 1. So that's a real easy one to calculate. If I put in -1 for x, I can see that I'm going to have -1 plus 2 as my exponent, which is just 1. And anything raised to the first power is the number itself. So then I can see that I get those 2 points right there. And coming over here, you can see actually that they made a mistake when they labeled this point right here. They labeled it as +1, -2/3. That should read, they have their signs wrong. So our points here do match up with what's on we see on the graph for B, and so we can say that number 4 matches with B. So 7 through 9 are going to be very similar to graphing the growth functions. It's now that we're going to expect the curved line to descend left to right, because as you can see, each of our B factors here in each of these problems is less than 1. So we're going to expect them to descend. We can also see that our A value here is 1 and it's positive. So we've got positive in number 8 as well, and we have a +3 here. So this number 9 is going to stretch a little. It's going to rise a little bit quicker than if the A value were 1. But it's still, none of these are inverted. We're still going to expect to see a normal descending curved line from left to right. So using our formula up here for these exponential equations, we can go through and think about what each of these things means. Our k values are going to give us our asymptote. So here we've got a k value of +2. So that means that we're going to expect to see this line approach y equals 2 without crossing it. Our asymptote here is -3, because again, we want this to be, it really needs to be written as a sum plus k, so this would be plus a minus. So that'll give us an asymptote at -3. That would put us right here in the middle of these two spots at y equals -3. And then over here, k value is 1. So there we would be at y of 1 with the asymptote. So remember, as we graph it, it's going to approach it. It's going to get as close to it as it can, but it's never going to touch it or cross it. And then we're going to need to look at the domain and range as well. So for number 7, we'll just make our xy table. And again, I'm looking for values that are going to make this a little bit easier to calculate in my head. If I use x of -1, it's going to zero out the exponent. -1 plus 1 would give me 0. That makes the 1/3 become 1. And then I have 1 plus 2, which will give me 3. If I use 0, again, that will give me an exponent of 1 overall. 0 plus 1 is 1. Anything raised to the first power is the number itself. So I'm left with 1/3. And I'll add it to that 2 to give me 2 and 1/3. I'll go ahead and plot those. -1, 3, and 0, 2, and 1/3. So just above that line. Okay, so we can see that we are descending. It's very slight, but we are descending. And we're going to get closer and closer to the asymptote without crossing it. All right, moving over to number 8, I'm going to try 0. And I think I'm going to try 0 and -1 on this one. The 0 will give me 1 minus 3. The negative 1, I'll come over here and show that the reason I'm choosing the negative 1 is because that will allow me to reciprocate this fraction, and I'll end up with 2 minus 3, which gives me negative 1, which is another nice, it's just an easy point to plot. So that would give me a 2 points at 0, negative 2 for the first one, negative 1, 1 for the second one. And I'm going to approach that line but not cross it. And then last one, I'm going to pick 2 because it'll zero out the 1/4 to make, it'll zero out the exponent so that 1/4 becomes 1. 1 times 3 is 3, plus that extra 1 is 4. And then I'm going to, I think I'm going to do 3 as well, because 3 take away 2 will give me 1. So I'll have 1/4 raised to the 1 power, so I just end up with 1/4 times 3. That gives me 3/4 plus 1, which would give me 1 3/4. So those are 2 points that are pretty easy to plot. 2, 4, 3, and 1 3/4. So that's just right over that asymptote. So we're going to come down with our curved line and get as close to the asymptote as we can without crossing it. Now we need to go back through all 3 and identify our domain and range. So on number 7, 8, and 9, you can see the domain for all 3 of those is all reals. So we've got domain for all 3 of these is going to be all reals. Again, if you're having trouble seeing that, then go through with a piece of paper and try to cover over the x values that will not be allowed, and then you'll see there's nowhere that you can put your paper down that would we would cover over x's that won't be allowed in this function. Now the range, what you want to look at for the range really is your asymptotes, because that's telling you the line that it can't cross, and it can't even touch it. So that, like a number 7, that tells us that everything above the asymptote is allowed, things below are not. So the y's have to be greater than 2. On this one, the y's have to be greater than negative 3. And on this one, they have to be greater than 1. Now, if these were inverted, if they had negative a values, then that would mean you're approaching the asymptote from the bottom, from underneath, and so then you would end up with less than signs instead. But when they're not inverted, then it's all the y values are going to be greater than the asymptote. If it's inverted, all the y values will be less than the value of the asymptote. Now this word problem is almost identical to the problem on the other worksheet, the previous one, except this shows decay instead of growth. We're going to be losing value on this car, this new car that was bought, as the years go on. It's not going to grow in value, it's going to decay in value. So we're to write an exponential decay model giving the car's value, V, in dollars after t years. They told you that you bought the car for $22,500 and it's going to decrease by 25% each year. So in the last lesson, you can see over here that I wrote out the exponential growth model for you. This is what we used in the word problem in the previous lesson. This is the exponential decay model. The only difference being that there's a difference inside the parentheses instead of a sum. But the value, the variables stand for the same thing. A is the initial amount. So in this problem, that's going to be the value of the car, 22,500. The R is the percent decrease. How much are we decreasing? In this case, it's 25% each year that we're decreasing. So we're going to subtract that from 1, which is 100%. We need to make sure we write that rate as a decimal, just like in the last, in the exponential growth model. That's what we talked about as well. And then T is the number of years that we are talking about the decrease going on. So how many years after the car has been bought in this problem. V, the dollars, corresponds to your Y, because that's the dependent variable. The value of the car depends on T, the number of years. So when I write that out, I'm just going to sub in v value for the y. I'm just changing the variable just so that I can remember what I'm actually solving for a little easier. My a value, like I said, is the initial price that you purchased the car for. And then the 1 always stays there. That's a constant. It's always going to be there. And I'm going to subtract from that this percent that it decreases every year. So 25% as a decimal is 0.25. And then we're going to raise that to t. So if I simplify that down, it would look like this right here. Okay, so now I can use that to find the value of the car after 3 years. So I'm going to find the value of the car at t of 3. All right, and when you plug all that into your calculator, make sure you use the caret sign, of course, properly to raise 0.75 to the third power. You will end up with this figure right here. So this isn't telling you how much it has decreased. It's telling you how much it's worth after the 3-year period, and since it's been decreasing 25% each year. On 15, they want you to approximate the worth of the car. How many years it's going to take for the worth of the car to drop to $5,300. So in order to do that, you're going to need your graphing calculators. So the first thing you want to do is put the number 13, where we simplified it, that function, into your graphing calculator in the y equals program. So you can see I have got the 22,500 parentheses 0.75. There's my caret, and then I went to the x key. You can see the x key right there. There's my exponent. So don't leave that part of it out, but you've got to make sure you have the caret in there so that it actually raises it to the exponent. It doesn't matter that it's an x and not a t. That's just the way the calculators work, so you can just leave it like that. It's still going to work the same way. Then you'll go to the graphing. Actually, go to window first and make sure your window matches mine. All right, you're going to need to be able to see y values that are pretty large because we're talking about the worth of the car. The worth of the car being $5,300. So that's why I raised my y max to 6,000 here. I dropped it, the y min, even though I know it's not going to be worth a negative $1,000, I dropped it down just so we could see a little bit more of the graph. But we're talking about years, and so we don't need a huge, that's our independent variable on the x-axis. We don't need a huge window for that. We should be able to see it with this window. And then hit your graph button, and it should pop up for you. And then you're going to use the trace button again. So we're going to go to trace, and you should pop up with the little cursor. You can use the arrow keys just like we did before to go up and down the line. We are looking for the approximate year when the car is worth $5,300. So 5,300 is my y. That's my dependent variable. So I need to go to y of 53. And so here I'm at 5,500. Here I'm at 5,100, but you can see my x value is 5.1 at 5,100, and it's, I went too far. It's 4.89 at 5,500, which is larger than we really want. So we're going to kind of estimate that in 5 years, we're going to have a car that is roughly worth $5,300.